Hi, everyone. I'm James.
I'm Diego.
Today we're going to talk about space.
Space!
I don't know if you could hear me at all in there. Today we're talking about space.
Gotta shut the lights off.
Oh, yeah, you got to turn the lights on. First, I'm going to let Diego introduce himself. Diego, why don't you tell them a little bit about yourself and why you are here talking about space?
I am here to talk about space because I love space. Space is like the most fascinating topic. I think even now, more than ever, like when you look at how small our planet is and all these things, you just get an appreciation for how big things are and some other big things that we need to worry about.
Yep. So you have like over 10 years of experience as a teacher in public school, in private school. You have been to NASA facilities several times.
Yeah.
Did something happen a couple of years ago that was really important?
Yeah. So I won this award. It's called the Alan Shepard Technology and Education Award, and it's awarded by NASA, the Space Foundation, and the Astronauts Memorial Foundation. So it's a big award. It's kind of like a Grammy for teachers.
Yep.
The truth is, though, here at Delphian, I learn from our educators every day. I got this big award, and it is very humbling, and it's definitely something to be proud of. But I also, when I meet people that have been in education for a long time, they are just inspiring, and you're one of them. I learn stuff from James all the time.
I just taught you something like 2 minutes ago.
Yeah. He's a total space enthusiast. When I first came to Delphian, we became good friends because we were just talking about SpaceX and all these different rockets and things happening in the space world. So
yeah, we wouldn't stop talking about space. So they figured they should put a camera on us and give us a webinar.
That's right.
So that's Diego. Those are all his credentials, and the things that make him a great person to talk about space. I'm James. I got none of that. I just love space.
James is awesome.
So let's get into this.
Let's get into it.
Hello to a bunch of people in the
let's find out who we have
in the Q&A section. All right.
Where's everyone from?
I might not catch everyone, and if I don't, that's totally okay, and I apologize.
Shout out to Logan and Greenwood.
Logan Greenwood, and hello to Lorna and Jacob and Shauna and Mackenzie and Denali, and Jack says he's been waiting since last week. Jack, me too.
Yeah, since last week.
Hello to April. Alette says we look awesome. Yeah, those helmets are a lot of fun. Should we do one next week on how to build a space helmet?
Yes, I think
okay,
so.
That's happening.
Okay.
Wow. Okay, I got to keep scrolling. We got to keep going. There's a ton here. Hello to everyone.
Yay.
All right. We are talking about space. Today we're going to talk about the solar system. And tomorrow we're going to talk about the broader universe and the rest of what's going on. But I'm just going to try to limit what we're talking about today to just a really, really close neighborhood around our planet and around our star. We're going to define some really key words, some important words at the beginning. If you know these words, that's totally okay. Just bear with us. Astronomy is the part of science that studies space. Fancy word, simple meaning. There we go. Celestial, having to do with the sky or with space. Okay. Some more words. Star, big ball of burning gas, huge ball of burning gas. Very simple. Sun is the star that our planet orbits. Other stars can be called suns too. But when we say the sun, we're talking about our sun. Sol is the Greek word for sun. And from that, we get the word solar, having to do with the sun. All right, so that's the first part of the word solar system. System. I'm just going to throw a lot of words here, and then we're going to get into the cool stuff. But you got to know the words before you can do the cool stuff.
Right. Even as you learn more and more about space, you always go back to the definitions of words.
Oh, yeah.
I won't get into it, but some planets get considered if they're a planet or not, just because of the definition. So
that's right. So a system is a set of things working together as parts of an interconnecting network. A bunch of things working together, like the internet. It's a system of computers and of information. If you have a bunch of schools that cooperate in order to teach students, that's a system. The highway system, it's a bunch of different highways all throughout the world, and they all interconnect to make one whole system. When we're talking about astronomy, it's a group of celestial objects moving in orbits around a center. Okay. Here's our solar system, guys. Let me make sure that we all fully understand stuff is big. It's really big. We can see the Earth here. The Earth is big. It's huge. It's way bigger than I am. But it's so small compared to some of the other things happening out there. Venus, you can see right next to us. Venus, the second planet in our solar system, it's about the same size as us. It's 7,500 miles wide, and the Earth is 7,900 miles wide. It's got similar gravity to us. It's the closest sister planet to us in terms of how it's formed and how big it is. But look at Jupiter.
Jupiter, sheesh.
89,000 miles wide.
Let's mouse over the storm, the perpetual storm that's on Jupiter.
Here we go.
Yeah.
That part there, I hope you can see my mouse hovering over that. That storm has been going for, at least 800 years?
Yeah,
and they think it'll keep going?
It's like a permanent hurricane on Jupiter.
Yeah.
That's bigger than the size of Earth.
It's bigger than the size of Earth. All right. I'm going to jump back into the Q&A really quick. Hadia from Pakistan, hello.
Wow.
Riley says, konnichiwa from Texas. I love space.
Yeah.
Konnichiwa.
Konnichiwa.
Oh, man. Hey, Jack says, maybe we could talk about nebulas. I really like them. I love nebulas. We're going to talk about nebulas tomorrow.
Yeah.
Because I like them. All right. Let's see. Lorna said, Shauna and I went stargazing last night. We almost never get to go stargazing in Oregon, so it was pretty cool.
Oh, I was stargazing last night too.
I was stargazing last night too. Here's the thing. I wander outside, I look up, I see the stars, and I just have to stop and just send my mind out into the universe to just appreciate the beauty and everything that's happening. Okay. Hello to the billion people. All right. Jupiter's big. The sun is huge. I couldn't even fit it in here. Just that edge, that slight curve right there, that's the sun. Jupiter is 89,000 miles wide. The sun is like, I'm 865,000 miles wide. 1.3 million kilometers. That's big. Here's another, now this isn't what it looks like exactly. They've photoshopped all these planets to be right next to each other so you could see relative sizes, but these are actual pictures of each planet. It's hard to see Mars because it's so small there, but that's an actual picture of Jupiter. You can see a little black dot right there. When they took that picture of Jupiter, one of its moons was in the way. Jupiter has what, like 30, 40
Something
moons?
like that.
A lot of moons.
Right.
And again, a moon is, a chunk orbiting a planet.
One moon on Jupiter has more liquid water on it than Earth.
That's Europa, right?
Yeah.
Yeah.
Just amazing what is out there.
Saturn there is still absolutely massive. It's a little bit smaller than Jupiter, which, is relative. And Saturn is my favorite planet. It's my wife's favorite planet. It's got the rings around it. We're at a pretty special moment in the history of our solar system because those rings weren't always there. And those rings won't always be there. If you come back in 200 million years, those rings will either be gone or they're going to look very different. They're definitely going to be smaller. And those rings, they are wide, many times wider than our planet, but they're not very thick. Some of those rings are okay, look at your floor. Good. Look at your ceiling. Good. Some of the rings of Saturn are that thick, are just that deep. If you're looking at them straight on, they're almost invisible sometimes. It's really incredible.
Yeah, when they were first observing Saturn, they didn't know what they were looking at because at different angles, the rings would appear to just go away.
Yep. Oh, someone's jumping in with Jupiter. Jupiter has 67 moons. Yeah.
67 moons.
Yep. Jupiter has its own. Akanksha. Jupiter has its own solar system. Yes and no. Yes, it has its own system. So again, a system, let me run back here, is a group of celestial objects moving around orbits in a center. So it's called the Jupiter system or the Jovian system. Just fancy word for Jupiter there. Yes, Jupiter has its own system. And Earth and Moon, you could call it the Earth-Moon system because we are orbiting around a common center. And the Jupiter system is in the solar system. Oh boy.
So many questions.
Good.
Can you imagine if we were all in a room together, we would just be chatting it up.
Mm-hmm.
Gosh, there's so many cool conversations.
Ethan asked, what are the tiny planets on the left? That's us.
Mm-hmm.
The first planet there is Mercury, small planet, very hot, very rocky, no atmosphere because it's so close to the sun, everything just baked right off, like the food that I left in the oven last week.
Yeah, just tore up by the sun. Some of the gases that can come off the sun, if the planets were this close to them, these solar flares would go around the planet if the planets were closer to the sun, like this picture. If this picture were real, the planets wouldn't be there.
Yeah. Good. So Mercury is the first planet, then Venus, then Earth, then Mars, and then we got the big guys out there. We're going to get a little bit more into that soon. Aubrey asks, what is a nebula? I said that word. I did not define that word. I apologize. A nebula is a big field of gas in space. How do you get nebulas? Usually from stars exploding. We're going to talk about that tomorrow. What happens when a star explodes? If stars never exploded, we wouldn't have life. We wouldn't have the really cool things in the universe. So we're going to talk more about that. Nebula is also a great character from the Marvel Cinematic Universe.
Mm-hmm.
Okay. Did planets used to be burning stars? Thank you, Mimi, for the question. No. That's a great question. I want to take that up in about 10 minutes. I'm going to come back to kind of how a planet forms, how a star forms. We're definitely going to take that up. Okay. And someone asked about Pluto. We're also going to talk about Pluto soon. Okay, let's go to our next slide here. Here's just some more slides looking at relative sizes. Relative is comparing one thing to another. So you see Earth on our top left there and Venus, just a tiny bit smaller than Earth. They're about the same size. Mars, I always think of Mars as kind of a second Earth, but it's much smaller than Earth. And it's got less mass. It has less stuff, less rocks, less everything.
Now the atmosphere is thinner.
The atmosphere is much thinner. The gravity on Mars is only what, like 1/6 of the gravity that we have here on Earth. We're going to look that up. Yeah. Mercury is even smaller than that. Pluto, if we move Pluto over, it would barely be larger than Australia. There's nothing wrong with Australia. But when we're talking about planets, it's, pretty small.
About a third.
Mars has about a third of the gravity. Okay. All right. All right. So here is another picture of different planets, and comparing the sizes. And you just see how tiny Pluto is. And then that's Mercury, and that's Mars, that's Venus, that's Earth, Uranus and Neptune, Saturn, Jupiter. Just comparing sizes. This is so much fun. And then you bring the sun into the picture and everything changes. You're like, wait, I thought that was big. No, it's small-ish. Okay. So let's bring this to like things that are real. What if Jupiter was a watermelon? I would eat it. Mm-hmm. If Jupiter was a watermelon, Saturn would be a very large grapefruit. I guess the largest grapefruit I've ever seen. Uranus would be an apple. Neptune would be a large lime. Mars would be a blueberry. Earth and Venus would both be cherry tomatoes. And Mercury would be a peppercorn before you grind it up into pepper. So, Diego, do you have any guesses about if the Earth was the size of a cherry tomato,
Mhm.
how big the sun would be. I would like you guys to put some guesses into the Q&A box. I'm gonna let him guess. I'm gonna let you guess.
My guess would be about the size of Delphian.
Okay, good. All right.
Maybe half.
All
Half
right.
the size of Delphian. That would be my
Very
guess.
good. Delphian is our school. That's where we're at if you're tuning in from very afar.
Four-story building.
It's a big 4-story building. Yep. Hartley says Saturn would be a cantaloupe. Yeah, I like cantaloupe better than large grapefruit. Thank you. That's good. All right. Minji says a house. Matthias says the size of a car. Mina says 10,000 times bigger. There we go.
Oh, yeah, I like the size of a car. For some
Yeah,
reason,
I like that.
sounds about, yeah.
That's good. Logan says 1 million cherry tomatoes. There you go. Yes.
I think I
That's
overestimated
actually
with
that's a
Delphian.
ridiculously good answer because right there on the screen it says the sun is so enormous that you could fit over 1 million Earths inside of it. Okay, that's a really good point.
1 million cherry
The
tomatoes.
size of a mansion, an apartment building, a pumpkin. Great. Huntley's got it right. Huntley says big. That's correct. All right. Well, you know what? You don't need to worry about that so much. I was using that page to help do some calculations. If the Earth is a cherry tomato, the sun's about 10 feet wide, so like a car, a big car, and is almost a quarter mile away, more than a third of a kilometer away from us. If the Earth was that big, it's like I can see a line of trees a quarter mile away right there. That's where the sun is. Space is massive. It's huge, and there's a lot of empty stuff. Good. All right. We're going to leave it on this screen here for just a moment as I pop into the Q&A box and answer some of your questions. Here we go.
1 million cherry tomatoes.
Great.
Yeah, when I heard somebody say the car, I forget who that was, but when they said the car, I went, okay, yeah. That actually...
That felt about right, yeah.
Reconsidering. Great job, whoever said that.
Yeah. Diego, what are we looking at here?
So this is the solar system. So this is a cross-section of the solar system. If you were to come out, maybe, from...
This is way up if you to go up from where the planets rotate.
Yeah, so there's a plane
Looking
where,
down.
where most of the planets are in orbit. And now these aren't in a perfect plane. Some of them kind of go about, our thing here. Need this? What do you
If let's say that we were looking, excuse me. There we go. Let's say we're looking down from the top onto our solar system. And here's the sun, and here's where Mercury orbits, and where Earth orbits, and where like Jupiter orbits. And we're looking at it, and it looks like a circle to us. But if you were to look at it from the side, it'd be very flat. Everything's orbiting around, everything's like one disk, and it's all orbiting around the same spot. Just like the rings of Saturn. They're wide, they're huge, but if you look at them from the side, they're very, very thin. We'll talk a little bit, I think a little bit more about why that is a little bit later.
Yeah. And that's the view that we're looking for. We're looking from that viewpoint. So if we went either north or south of the sun or north or south of the Earth, you would see the orbit, something like that.
Good. Moises, I should hire you. He says, are we going to talk about the asteroid belt? Yes! So, Mercury, Venus, Earth, Mars, these lines are showing the orbit that these planets have. And the very next slide here, so that tiny little inner circle, that is Mars's orbit. And we can now see where Jupiter and Saturn and Uranus and Neptune have their orbits in between Mars and Jupiter, kind of right where I'm moving my mouse there. It's what's called the asteroid belt. There's a bunch of asteroids, a bunch of just chunks of rock that never really stuck to a planet orbiting in there. Now, Diego, have you seen Star Wars?
Oh, yeah.
I've seen Star Wars. Probably most of us have seen Star Wars or some movie where you see a spaceship moving through an asteroid field. And there's sometimes like a like ships chasing each other through the asteroid field, and there's chunks of rock everywhere, and they're colliding into each other. And
there's video games where you have to dodge the asteroids.
Video games where you got to dodge the asteroids. I'm so sorry, but real life asteroid belts are nothing like that, because it's so spread out. It is so far away from one another. You could pick just about any direction in an asteroid field and fly straight, and the chances of running into anything are very, very small, because even though stuff is big, space is bigger, way bigger, way, way, way bigger.
One of our alums from Delphi, LA, he got to see some of the first returns of a chunk of asteroid or a chunk of meteor, where they had a mission. They picked it up. I don't remember the name of that mission. But but they returned it. So we got some cool space background people.
Yeah. We have a couple people asking about black holes. We're going to talk about those tomorrow. We decided to just limit what we're talking to today, just about our solar system, the sun, the planets, some of the other stuff flying around our sun. Okay. Someone says they love Star Wars. Very good. Okay.
Oh, I got to ask this question.
Yes.
Who out there has a solar system built in their room? I think that's a really fun project. If you don't have one, build one. You can make it out of cardboard. You can scale it. So some of the scale that we're studying now, how big the sun is compared to how big the Earth is. Having that in your room is the coolest thing. There's glow-in-the-dark kits you can order, but if you like space, put a solar system in your room. It's the coolest thing.
All right. Nate has one there.
Oh, nice.
All right. That's awesome.
Amelia, she has one.
Yeah. All right. What's next? What's the next slide? I forget. Oh, yeah. So if we go out even farther than those 8 planets, some of you keep asking about Pluto in the comment section. We're going to talk about Pluto. We're going to talk about Pluto. Don't worry. So between Mars and Jupiter, we have the asteroid belt. And out past Uranus and Neptune, we have what's called the Kuiper belt. It's named after a guy he was an astronomer back in the days, and he, discovered some stuff and figured a lot of stuff out. So they named it after him. And think of it as like another asteroid belt, just further on, out past Uranus and Neptune. And there's a bunch of asteroids out there. There's going to be some comets out there. You see it kind of like a snowy ring or a snowy belt around our solar system in this picture. This isn't what it looks like to the human eye. To the human eye, it looks like empty space. But if you're looking at it with the right telescopes and the right instruments, you can pick out that there's bits of stuff flying around out there.
Right. That's one of the things that I advocate for space and why we need to study it, is because being on Earth, there is so many things that have the potential to impact Earth. Back in 2000, I forget where the Russian, where that.
I think it was 2011, 2010, something like that.
On TV, they caught meteors coming into Earth. I mean, it was just like these things were coming in, or one of them came in and destroyed some buildings, hit with a certain amount of atomic force. We have direct TV. We have all these systems. We have a lot of home entertainment satellites, but we actually have really few asteroid tracking satellites. I think we need to up our game on that for planetary defense.
I agree. It's been said that the dinosaurs did not have a space program. And the dinosaurs are no more. The dinosaurs are around for hundreds of millions of years. We've been around for 10,000 max, something like that. So we're ahead of the dinosaurs on the whole space program thing. I am also a big fan of looking out from Earth, looking away from Earth, looking into the solar system and tracking these different asteroids and stuff that are flying around and figuring out which ones are going to hit us and when, so that we can stop that.
Yeah. One of my good friends, Loretta Loretta from her husband's the CEO of Virgin Galactic. The other day for Yuri's night, she said, "We're all crew Earth," and I love that.
Crew Earth, I like
Yeah,
that.
yeah.
Yuri's night is a night where they celebrate space and space exploration. It's named after Yuri Gagarin, who was the first human in space. Good job, Yuri.
Yeah, yeah. And we're not passengers on Earth. We're crew Earth.
We're crew.
Yeah,
I like that.
We're all crew.
We're not just along for the ride. We're part of it.
Yeah.
We're working together. Mason asks, what is a comet? I had another slide that I actually took out where I talked about comets. I should have left it in. So you've got the sun, huge ball of burning gas. You've got planets. You've got balls, big balls of rock or gas that orbit the sun. You've got moons, which are smaller chunks of rock. And then you've got your asteroids, little rocky bits, and comets, which are little icy bits that are just flying around the solar system. There's millions of them. Sometimes a comet gets too close to the sun and it starts to evaporate. It starts to burn and boil and melt away. And then you can see it. But think of it as a giant snowball, a dirty snowball flying through space. That's what a comet is.
Dirty snowball. I like that.
All right, Logan asked, why can't dinosaurs clap? It's because their arms are short and they're dead. Okay, so what's next? Oh, another picture of the Kuiper Belt. All right, everyone. So you see this orange ring here? That is Neptune's orbit. My mouse is somewhat following it. And that yellow ring, that's Pluto's orbit. You can see Pluto orbits not exactly the same way as all the other planets. I was talking about, I know I'm on the small screen here. I was talking about how our solar system is very flat and everything orbits along together. Not everything does. Pluto goes on a slightly different loop. It's kind of sideways, as you can see there. But you can see the Kuiper Belt here. There's all these objects floating around out, past the outer planets.
And just recently, the first images of Pluto were taken. I was at Space Center Houston, got to meet Alan Stern. He's the principal investigator. He signed a book for me. I gave one to James. And the New Horizons mission, they were able to take some of the first photographs of Pluto. A lot of people don't know this, but the microchip on the New Horizons mission was from an Xbox, I believe. It was a video game console system. And it's just because those chips are so reliable. Now, they had to soup it up to get it ready for that, but that's what they were using to take pictures of Pluto.
I love it.
Yeah.
I went to Pluto and I could have played Xbox. So someone asked really quick, where'd it go? Okay. I remember the question, I just don't see it on there anymore. What's the difference between a meteor and a meteorite? A meteor is when an asteroid, rocky bit floating through space, is when an asteroid hits the Earth and it comes through the Earth's atmosphere and you can see it burning up in the atmosphere as it comes down. That is a meteor. When it comes through the atmosphere and it hits the ground and all that you've got left is like a chunk of rock, that's called a meteorite. The meteor is when it's still coming in. Meteorite is once it hits the ground. Okay. Now, there's a few things on here. We see the words Voyager 2 and Voyager 1 and Pioneer 11 and 12, New Horizons. These are all spacecraft, probes, missions that we have launched from Earth and sent it out into our solar system to go take pictures and scientific readings of different things in our solar system, planets, stuff like this. What Diego here was talking about, New Horizons, it launched from Earth and we sent it on a very special path that takes it right past Pluto. And it went right past Pluto. It took a ton of pictures and gathered a lot of information. And it is going so fast, it'll never come back to our star. It'll never come back to our sun. It's heading out of our solar system, and it'll just keep going until it runs out of battery. The next target that they have it sent on, the next thing it's going to go past and take a bunch of pictures of is an asteroid out here in the Kuiper Belt called MU69. and MU-69 just happened to be on its way. So it's going to drive by it. It's going to take a bunch of pictures, send it back to us, and we'll learn more about MU-69. Someone asked, why is it called the belt? So again, it's called Kuiper Belt. Kuiper because it's named after a guy whose last name was Kuiper, who helped discover it. And belt because it's kind of like the solar system is wearing a belt, like you sometimes wear around your pants. Yeah. Okay. Oh, Pam asks, what happens if the spacecraft breaks? Then it's broken forever, and it's kind of a bummer. I don't know if the Pioneer spacecraft are still operating or if they've broken or run out of battery. But Voyager 1 and 2, they launched in 1970 something. They're still working. They're still working. They're still going. I've had 3 cars die in the last like 20 years. And Voyager 1 and 2, which are much older than those cars, are still going. They are so far away from our star.
They're cold.
They're cold and they're still running. They will run out of energy eventually. They will break eventually, and we will lose contact with them. And that's okay. Those missions were only planned to last like 10 years or something like that.
That's the amazing thing that they get out of NASA science is they, some of the engineers there, they need to be put on a pedestal because some of their missions go years longer than they initially planned for. So great stuff going on.
Yep. Okay. So at these distances, at those scales, oh man, we are not going to have enough time to cover everything today. I'm going to speed up a little bit. You were right.
We have a lot of shows to talk about.
How do we measure distance in space? You could start with miles and kilometer. Those are very useful to start with. But that would be like trying to measure countries on Earth with inches and centimeters. It starts to become not very useful because the scale is so different. So
that's a great analogy.
Yeah. So let's define some more words here. The astronomical unit, the AU, and that's the distance from the sun to the Earth. That's a nice distance that we can think of. It's useful. It's about 150 million kilometers or 93 million miles. So now if I'm talking about something way out there, I don't have to say it's a gajillion trillion miles. I can say it's 200 AU, 200 times the distance from the Earth to the sun.
It gives us a measuring stick. It gives us a measuring device.
Yeah.
Yeah.
And then a unit of measurement that we're all familiar with the name, which is a light year, or some of you might know the terms light minute or light second. A light year is the distance that light travels in 1 year. How fast does light travel? Light travels super fast. It's about 186,000 miles per second, or 300,000 kilometers per second. That's super fast. So a light second is about 186,000 miles. A light minute is how far that light would go in 1 whole minute, is about 11 million miles. And a light year is 5.8 or 5.9 trillion miles. That's a lot. But it's useful when we're talking about the universe and when we're talking about stuff outside of our solar system.
And James has a really cool thing.
I
can't wait for you guys to see this. James just showed me this morning, and it's a way cool graphic.
Yep.
I'm talking to James to see if he can come to our SEEK conference in Space Center Houston. Every year I go, and I learn tons of stuff from teachers around the country, and I think James would fit right.
Yeah.
in.
Oh, thanks.
Yeah.
What if the moon, so let's look at a scale. We were talking about the scale, like what if the Earth was a cherry tomato? What if we took our screen and we did that? We looked at a scale. If the moon were only 1 pixel, a pixel is 1 bit on your screen that makes light, and your screen has thousands of pixels.
They almost look like dust. So if you're looking at your screen right now, there's
Scroll along.
Yeah, there's little tiny specks.
All right. I don't even know if this comes through on the broadcast here, but right there where I'm circling my mouse is 1 pixel, and that is our moon. and it's about 3,400 kilometers wide, and that's roughly the distance from New York to Las Vegas. At that scale, the sun is this big, and I'm going to click this button here. That's going to start moving us through our solar system at the speed of light.
So I just to get an appreciation, what is happening now? What is our speed? Tell us about that.
We're moving 186,000 miles per second in this illustration here, in this demonstration. We're going.
And like if the sun went out, we wouldn't stop seeing light for about 2-3 minutes.
A little bit more than that. Okay, here we go. We're still going at the speed of light. That distance that we traveled from the sun just now, that was about 10 million kilometers, about 6.2 million miles. We're just going along. We are going as fast as you can possibly go in the universe. We're just going.
At least with the math that we have now.
That's right.
At
And we're
least
just
with
going.
what we have now, what we understand now.
I know this feels like we're just staring at an empty screen, and you're absolutely correct. All right, so that was 1 light minute. Where is everything? Okay, now I'm going to scroll
So
along.
James, have we passed any planets yet?
Nope, we're not even close. That was 1 light minute. I'm now going to cheat. I'm going to scroll faster than the speed of light. It's pretty empty out here. Still scrolling. Still scrolling.
Look at those minutes
Yep.
going by.
Here comes our first planet. There's Mercury. 3.2 light minutes.
Look how
From
tiny that is.
the sun. This is there's a ton of stuff packed into this website. You can see the link up on top of the screen right there. Or you can just Google if the moon were 1 pixel, and it'll take you to this website. I'm going to scroll this for just a tiny bit here and move on, but there's a ton of stuff. We're going to move on from Mercury. As it turns out, things are pretty far apart. 4 light minutes from the sun, 5 light minutes from the sun. We'll be coming up on a new planet soon.
So it is
Sit
8.
tight. Moving along. There's Venus, about 6 light minutes away from the sun. Moving on. Most of space is just space. Halfway home. I hope you guys are as fascinated looking at a completely blank screen as I am. Like, there's so little out there. Here's the Earth, 8.2, 8.3 light minutes away from the sun.
So if the sun goes out,
We'll know it in about 8.5 minutes.
Wow.
Yeah, a little under
Yeah.
8.5 minutes.
wow.
Look outside your window right now and take a look at the sunshine. Do you see that sunshine? That light was at the sun 8.5 minutes ago. You're not seeing it right away. It takes 8.5 minutes. Okay. I got to move on because I'm just getting super excited here. Because the next thing is even cooler. Let's make our own solar system. You want to make a solar system?
Let's make it.
Let's make a solar system. You can Google gravity toy. It's from a website. It's called Nowy Courier. I actually don't know what that means. Maybe that's a guy's name, or maybe that's just the name of the website. I probably should have looked that up. He has this really cool thing here. We're going to make a solar system. We're going to start by creating just a disk of dust. Just dust and gas in the middle, and we're going to see what happens. Right away, that evenly spaced bit of dust and gas, it starts to come together and to form certain things. Right away, we can see a basic solar system here. In the middle, you've got your sun. You've got stuff orbiting around it. Those are probably planets. You can see smaller bits flying out towards the edge of that solar system. That's your early Kuiper belt. Those are asteroids and comets and things that are not going to get sucked into a planet, or that are not going to get sucked into a star, and that are going to just kind of hang out way out at the edge of this solar system.
And does anybody there see Earth Moon type system forming, or
Yeah.
a planet Moon type system?
I'm going to turn on this thing. I really hope that this comes through clearly on the broadcast here. All right, well, all right, I'm going to clear this. I'm going to start it again. Every time you do this, it's going to look different. It starts with the exact same circumstances, the exact same. It's 1,000 bits of dust and gas, equally spaced, and it instantly starts to form something like this. This is how a solar system is formed. You've just got a big cloud of dust and gas, and it just starts to press together a little bit, and things start to clump together. Like if you have a bunch of people in a room, they're just going to walk over and start talking to one another. They just can't not. They're just going to be like, fine. Hey, how's it going? What's your name?
Diego.
Oh, cool. And then other people are going to come over and start talking to you. And the universe likes things to be together.
Yeah. And just recently, in the past 5 years, I believe, NASA has found an area that has, it's a planet that goes around 2 suns.
Yeah.
So they have a 2-sun system, and they named the planet Tatooine.
Yeah.
In honor of Star Wars. That's where.
So this system that we're looking at right here, this fake solar system, this looks like it might have 3 suns. You can see the big red one, and then a smaller one orbiting it, and then a bigger one orbiting that. The closest planet, the closest star to our star is called Proxima Centauri. And it is really, really close to us. It is only 4.2 light years away.
It's in our backyard.
The light from our sun that's leaving right now will be at the closest star to us in 4.2 years, moving at light speed. It's that close, and it's that far away. Proxima Centauri is a 3-star system. It's got 3 suns.
Oh, I didn't know that.
Yeah.
Gosh, I learn every day.
Every day we learn something new. Oh, man, we are running out of time here. Okay. I promised that we would talk about Pluto. So what happened to Pluto? Why don't we call it a planet anymore? If I were to go back 20 years, Diego, and find you 20 years ago and tell you, hey, so guess what? In the year 2020, things are pretty exciting. We're all on like a global quarantine lockdown, and there's only 8 planets in the solar system. You would think that something really crazy happened.
Fact is stranger than fiction.
Pluto still exists. We just call it a dwarf planet now. We don't call it a full planet. We call it a dwarf planet because as we discovered more and learned more, we found a ton more stuff in our solar system that was about the same size. So here you see our moon. This is how big Pluto is compared to our moon. We started finding a ton of other stuff in the solar system like this. There's a thing called Eris. There's a thing called Haumea and Makemake and Ceres. And these are all out in that Kuiper Belt that we were talking about. It's just chunks of stuff flying around out there. Some of it's big, some of it's little. There's chunks of rock in the Kuiper Belt no bigger than this. And there's chunks of rock out in the Kuiper Belt bigger than Australia, like Pluto and Eris. Where am I going here? Here's some more dwarf planets. Sedna and Quaoar and Salicea. There's some really cool names out there, you guys.
I love Makemake. That's my
Makemake, yeah. So if we had kept calling Pluto a planet, we would have to call Eris a planet, and Makemake and Sedna, and maybe this one that doesn't even have a name. It's called 2007 OR10.
Then you might have a teacher that makes you memorize them all.
I'm not going to do that. Here's the one thing I want you to memorize because we're running low on time. Space is big. Stuff in space is big, but space is even bigger. We're out of time. Oh, no. Okay, come back tomorrow. I am going to cover the rest of what we have in here, and then Diego's going to talk about the universe. There's a little bit of a teaser. All right. I need to go forward really quickly. Okay. Thank you for attending. heronbooks.com has a ton of awesome curriculum that I totally steal from to put together these slideshows and stuff like that. Our school, the Delphian School, uses Heron curriculum. Go there. Anything you buy there, you can get 30% off right now with the promo code Delphian30.
The courses are step-by-step, level by level. Parents can do them with their student, or the student can do them by themselves. I have encouraged my team of educators to start looking at this for, education in public school. I was using it at my public school. It's great curriculum.
Yep. All right, everyone, we got to run. We'll see you tomorrow.
All right.